In today's applied animal feeding lesson, we're going to learn about mixes. And what I mean by mixes is that sometimes as nutritionists, we have to blend some ingredients together to create a mix that goes into a larger ration. And so this is simply a blend of feeds that can act like an ingredient. Or its own feed. So for example, show feeds that people utilize for showing livestock are mixes of various ingredients, but when we give it to our animal, we tend to think of it as one feed. Sometimes there's vitamin and mineral premixes that are given to or put into animals' rations to support metabolic functions, and those are premixes that are administered. And so when we blend a mix, there's times that we need to estimate the nutrient content of a mix. And while we do have spreadsheets and a lot of things that can help us do that, again, it's the importance and the critical thinking skills to be able to understand how to do that and where those numbers come from. And it's a lot like creating a weighted average, so to speak. And when I say that, it's basically taking the nutrient concentrations and figuring out how much of each nutrient is coming from each feed source and getting an average for that new feed mix. I believe that it's best learned in using examples. And so for this example, we're going to look at the dry matter, the energy in megacalories of net energy for maintenance, and the crude protein of a mix of feeds. A lot of times if we go into a feed store, you can buy what is called COB, C-O-B. And that just stands for a corn, oats, barley mix. And so I've created a fictitious COB that we're going to utilize and calculate these parameters for. And so what we need is the base ingredients. And that is going to be corn, oats, barley, and I do have them processed various ways, like a rolled oats, which is almost like a cracked oats, plain oat grain, and we have some steam rolled barley. And so we're going to have to look those up in a feed library somewhere and get the dry matter, the net energy for maintenance, and the crude protein for each one. I also, in this fictitious mix, COB mix, made it a molasses-based mix and have some beet molasses to kind of hold it all together and make sure everything is distributed evenly within it. So the first step in and this is kind of the beginning of the ration formulation videos I'm going to be making, I always gather all of my data first and then start on the problem solution. It helps because then you're not interrupting your thought process to go back and look for data. You have it all in front of you. So to look up feeds, I'm going to use my feed table that I've been working on and creating. However, I can recommend to those of you out there, the Noble Feed Library is a great online resource, and there's several other places, textbooks, other feed libraries online that you can find feed nutrient content information. So we're going to work with these three, and the first one is going to be rolled corn. So let's look up our corn products. Let me scroll up. Oh, and there's lots of them. And here on row 18 is corn grain rolled. That's the one I'm going to be using because it says rolled corn. So our dry matter is 88%. Our net energy for maintenance is 98. And this is important to note that it's megacalories per hundredweight, which we'll talk about. Oops, I just realized my paper had moved, which we'll talk about a little bit later. And then if I look up the crude protein, I find that corn is 9%. We'll do the same with oats. And it's just the plain grain. 89% dry matter. 11.16%. Now that we have all of our feed information, we can start figuring out our ration. The last piece of information we need is the proportions. And in this ration, corn is going to be 40% of the ration. Oats is 20%. Barley is 30%. And the molasses is 10. Now, if you notice, these numbers add up to 100. So this could be either percent or 100 pounds as fed. I like to start and convert percentages just mentally, treat them as if they are pounds as fed. Because now we can use one of our key formulas that we've used in previous problems. The amount times the nutrient concentration will give us the nutrient amount. So that is a key formula in animal nutrition. And that's what's going to tell us how much of each of these nutrients of dry matter, energy, and protein is in this mix. So the first one we're going to do is dry matter. So we want to determine how many pounds of dry matter are here. So we're going to take our amount, which is the amount as fed. What we don't know is our dry matter, times the nutrient concentration, in this case, the dry matter values, on a decimal basis. Let's make a note. The decimal form. Okay? So instead of 88%, it would be 0.88. That's going to tell us how many pounds of dry matter. If we go back and you review the dry matter to as-fed conversions, you'll remember that mathematically we're removing the water, so we should reduce the weight and get a smaller number going from as-fed to dry matter. The oats are 89% dry matter, so we're going to do the multiply by the decimal form, 0.89. Barley is 86%, multiply by the decimal form of that number, and the molasses is 77%. So we're multiplying by the decimal form. By doing that, we will be getting the pounds of dry matter for each of these nutrients. Make sure that's how I say it. So 40 times 0.88 gives us 35.2 pounds of dry matter. That number is smaller than 40. It's probably accurate. And so we went the correct direction. That's an appropriate number. 20 times 0.89 is 17.8 pounds of dry matter from the oats. The barley is 30 times 0.86. We get 25.8 pounds of dry matter. And the molasses is 10 times 0.77. We get 7.7. Now, we know that we should have less than 100 pounds of feed because we reduced the water and lowered the weight. So if we add up all of these numbers, 35.2, get the calculator, plus 17.8, plus 25.8, plus 7.7. So if we add up all of these numbers, we get 86.5 pounds of dry matter. Now, the other important calculation that we're going to need is how to calculate a percentage. And I define a percentage as the part divided by the whole times 100. Okay? So for this example, our part is the smaller proportion, right? Well, and that's not always smaller, but our part is the pounds of dry matter. So that is 86.5. Our whole is what we started with, or 100 pounds of dry matter. If we multiply that by 100, which in this case 100s will cancel out, that is 86.5% dry matter. That would be the answer for how much dry matter is in this cob mix. It's not too bad. So we're going to take this process and do it essentially 2 more times with one caveat. So I'm going to transfer some numbers, the corn, the oats, the barley, and the molasses. However, when we looked up this data right here in the feed library, this was on a dry matter basis. So the starting weights are pounds that we're going to start with are the pounds of dry matter, because we have dry matter pounds and nutrients on a dry matter basis. So this column here is what we're going to start with. So we carry over the 35.2 pounds of dry matter from corn, the 17.8 pounds of dry matter from oats, the 25.8 pounds of dry matter coming from barley, and the 7.7 pounds coming from molasses. So together, those totaled 86.5 pounds of dry matter. Okay, so now it's going to be back to that equation of amount times the nutrient concentration. That's going to be what gives us our megacalories of NEM. Now, if you remember when we looked up the megacalories of NEM, they were on a 100-weight basis. We need to convert them also to a per pound form or a decimal form. So we're going to where this says 98 megacalories per 100 pounds, we're going to use the decimal form, 0.98. How many megacalories are in 1 pound? The oats was 81, so we're going to use the decimal form, 0.81. Barley was 92. We're going to use the decimal form of that. And the molasses was 79. We'll use the decimal form of that. So now we're just figuring out how many megacalories are coming from this 35.2 pounds of corn. So I'm entering this formula into my calculator, and I'm going to round to 2 decimals for consistency, 34.50 megacalories of net energy for maintenance. And that makes sense because it's almost 1, so it shouldn't have changed a whole lot. In fact, these shouldn't change drastically. They're pretty high concentrations. I'm putting the oats equation into my calculator, and I get 14.42 megacalories of net energy for maintenance. I'm going to do the same for the barley, and I get 23.74. And finally, our molasses. If I resolve that one, we get 6.08. So if we sum all of these megacalories, which I'm just typing into my calculator, you can solve using your phone calculator, put it in an Excel spreadsheet, find an online calculator, whatever works for you. I still happen to like the feel of real buttons on a calculator and not my phone. I hate my phone calculator. And plus, my phone is doubling as the camera right now. So in this amount of dry matter, we have 78.74 megacalories of net energy for maintenance. Now, on this one, we're not going to calculate a percentage, but we would like to know the megacalories per pound of dry matter. So to do that, we're still going to take the part 78.74 divided by the whole. And that is going to give us our answer, which is 0.91 megacalories of net energy for maintenance per pound of dry matter. So you notice that this number is kind of in the average realm of these that are our sources. And so that's always a check. Your answer must always be in the range of the numbers given to you. Finally, we're going to set up our mix to calculate the percent crude protein coming from each of these, coming from this total mix by identifying how much protein is coming from each ingredient. Similar to the previous step, we want to start with the pounds of dry matter. And I can really recommend, as you're starting out learning about animal nutrition, no matter what stage you're at, label everything, set yourself up in organized tables to set yourself up for success. It's really hard to start digging around to find what number did I use where. So you'll notice I use a table structure, very linear, and it's what keeps me organized as I'm doing these. So I'm going to carry down the pounds of dry matter because I want to know my crude protein on a percent dry matter basis. And we're going to use that same, oh, no, that is not the number I wanted to write in there. God bless whoever invited whiteout. 7.7, that totals 86.5. So we're still going to do amount times the nutrient percentage, and my data is coming from that feed table. So we're using the decimal form of the crude protein values. And right now, looking at this, I know my answer is going to be somewhere between 9 and 12, because that is the only possible range that I have for answers to be within. So we'll start with corn, and this is the pounds of crude protein, and multiply by 9%, or decimal form. We got to remember 9%, you still move the decimal 2 places, so there's a 0 in front of it. The oats was 11.16%, barley was 12%, and the molasses was also 9%. So if we run these through the calculator, the 35.2 will start with corn. I get that about 10% of it is 3.17 pounds of crude protein, rounding up to 2 decimal places. 17.8 times 0.16 rounds up to 1.99 pounds of crude protein. The 25.8 times 12% gives us 3.10 pounds of crude protein. And finally, 7.7 times 0.09 or 9% gives us 0.69 pounds of protein. We're going to add those up. So I'm just moving down the line. So there's 8.95 pounds of crude protein, because that's what we solved for, in this amount of dry matter, in 86 pounds of dry matter. So to get the crude protein percent, we're going to take the part, 8.95, divided by the whole times 100. So the part divided by 86.5 is 0.10 times 100 tells us that this ration, the crude protein percent, is 10.35% on a dry matter basis. And so for this corn, oats, barley mix, we learned that the dry matter percent was 86.5%. It contains 0.91 megacalories of net energy for maintenance per pound of dry matter, and is also 10.35% protein on a dry matter basis. So this can work for any number of ingredients and any number of nutrients. We didn't have to use just dry matter, protein, and energy. This could have been done with fiber. This could have been done with calcium, phosphorus, any of the nutrients that we work with. And so this is just an example of how you can solve for the amount of nutrients in a mix.